Hi, this is Vivek. Today we are going to discuss about current electricity on online Guru. Current electricity. What is meant by current electricity? Current electricity is a branch of a physics. It explains the properties of electric charges under the motion. A branch of a physics which explains properties of a motion of electric current or electric charges is said to be electric current or current electricity. In this electric current or current electricity, we are going to define term by term. The first one is a charge. What is meant by charge? How to define the charge? Charge is a property of the conductor or the property of a body. It produces electric field and experiences a magnetic effect. Charge is a property of a body. It produces electric field and experiences a magnetic effect. Charge is denoted by a lowercase alpha beta of a Q or a higher case alpha beta of a Q. Charge is measured in two different type of units. One is a CGS unit. CGS, centimeter gram system. In this CGS system, they can set it to be a unit of electrostatic unit. This only called as a stat coulomb. Then another one is the SI unit. What is a SI unit of a charge? The SI unit of a charge is a coulomb. Simply it can represented as a higher case alpha beta of C. So coulomb is the SI unit of a charge. Then what about the dimensional formula for the charge? The dimensional formula for the charge, that is charge Q is equal to current I into time according to the definition of a current. From this we can write the dimensional formula, that as m power 0, L power 0, P power 1 and I power 1. This is the dimensional formula for a charge. When we know the charge, then we can define the potential. The second case we can define as a potential. What is meant by potential? Then what is the unit of a potential? What is the dimensional formula for potential? These we are going to learn now. Potential. What is the potential? Let us take a conductor. When we take the conductor, therefore in this conductor having the two endpoints. In these two endpoints, first endpoint I call as A, another endpoint I call as B. At endpoint A, maintain majority of positive charges and then minority of negative charges. Vice versa, at end B, majority of negative charges and minority of positive charges. These both ends maintained different charges. One is a positive charge, another one is the negative charge. This positive charge we are carrying or bringing from one endpoint of the conductor to the another endpoint of a conductor. The work done is required. The work done which we are doing, that work done can be represented as a W. Therefore, unit positive charge is bringing from one endpoint of A to another endpoint of B. The work done is required. That work done can be represented as a W. Therefore, unit positive charge is bringing from one endpoint of a conductor to another point of the conductor, or from one point to infinite distant point. The work done is said to be potential or electric potential. Potential can be denoted as V, which is equal to work done we can represent it as a W, then charge can be represented as a plus Q. This is the mathematical equation for the potential. Once again I am repeating, the statement for the potential. Unit positive charge is bringing from one point to another point, or from one point to infinite distant point. Work done at this point or work done at that point is said to be its potential. Potential can be denoted as a V, that is equal to work done by charge. So that the mathematical equation for the potential V is equal to W by plus Q, or the Q. This is the mathematical equation for the potential. When we define the potential, then we can write the units for the potential. This is a derived physical quantity. Due to that, we can write only the SI unit, that SI unit of a potential. What is the SI unit of a potential? Here, the SI unit of work done is a joule, and then charge is a coulomb. Therefore, the SI unit of a potential is a joule per coulomb. This joule per coulomb they called as or they said to be volt. This volt can be represented symbolically as an higher case alphabet of V. What is the volt? How they are defined the volt? Volt is we can write like this: 1 volt is equal to 1 joule is divided by 1 coulomb. 1 joule by 1 coulomb. Therefore, 1 coulomb of a charge bringing from one point to infinite distant point, the work done is 1 joule, then it is said to be 1 volt. 1 coulomb of a charge bringing from one point to infinite distant point, work done is required 1 joule, then it is said to be 1 volt is the definition for the volt. This is the mathematical equation for writing the volt. When we can write the mathematical equation for a SI unit of a potential, then what about the dimensional formula DF? Dimensional formula: joule is an SI unit of a work done. Work done dimensional formula m power 1 L square T power minus 2 is divided by, then charge dimensional formula is I into T. This is the dimensional formula for the charge. Then simplifying this equation, we can write the dimensional formula for potential m power 1 L square T power minus 3 I power minus 1 is the dimensional formula for a potential. When we are writing dimensional formula for potential, now we will come to our lesson topic, our topic, that is a current electricity or electric current. What is meant by current? How we can define the current? How we can define the current? Let us consider the conductor. When we consider the conductor, in a conductor, charges are moving randomly from one end to the another end. When the charges are moving randomly from one end to another end, therefore amount of a charge passes through the cross-sectional area of a conductor. That amount of a charge we can represent it as a Q. Time taken to crosses the cross-sectional area is a T. Therefore, amount of a charge passes through the cross-sectional area of the conductor per unit time is said to be its current or electric current. Current or electric current can be denoted as I, which is equal to charge by time, which is equal to charge by time. So that rate of charge flowing through the cross-sectional area of the conductor is also said to be its current or electric current. Mathematically, we can written it as I is equal to Q by T. Here Q is the charge and T is the time. Then I is the current or electric current. What are the units for the current or electric current? According to the principle of a quantization of a charge. According to the principle of a quantization of a charge means an integral multiples of a charge of an electron is said to be quantization of a charge, then Q can be written as N into E. E is the charge of an electron, N is the number of electrons present in that, is divided by T, is another mathematical equation for the current or electric current, that is equal to Ne by T. E is the charge of an electron. The charge of electron E is equal to 1.6 into 10 to the power of minus 19 coulombs. This is the value or a standard value or a constant value for the charge of electron. Then current equation, mathematical equation for the current I is equal to Q by T. When we know the mathematical equation for the current, then we can write the units of a current in SI system as well as a dimensional formula for the current. Now we can write the units of a current. Now unit of a current, the SI unit of a current. SI unit of a current, according to the mathematical equation, current I is equal to Q by T. Then unit of a charge is a coulomb. Then time is a second. So that coulomb per second is an SI unit of a current. This coulomb per second, they said it to be as an ampere. According to the memory of an ampere, they define the SI unit of electric current as an ampere, that is coulomb per second. What is the statement or the definition for ampere? That is 1 ampere is equal to 1 coulomb. 1 coulomb by 1 second. 1 coulomb by 1 second. So therefore 1 coulomb of a charge passes through cross-sectional area per second, then it is said to be ampere. Amount of a charge passes through the cross-sectional area of a conductor per second, or 1 coulomb of a charge passes through the cross-sectional area of the conductor per second, is said to be 1 ampere. This is the mathematical equation for the definition of SI unit of current. When we are writing the unit of a current, then what about the dimensional formula for the current or electric current? The dimensional formula for current or electric current is a I, or we can written as a. This is the dimensional formula for current or electric current, because current or electric current or amount of a current is the fundamental quantity in SI system. Due to that, a dimensional formula or A. This is a SI unit for the current. When we are knowing the SI unit for the current, now we can learn today class. One is a definition of a charge, second one is the definition of a potential, then another one is the definition of a current. When we are define the definition of a charge, potential and a current, then now we are going to discuss about the most important concept in the current electricity, that is Ohm's law. What is the Ohm's law? Ohm's law. George Simon Ohm introduced a law, that is the relation between current and the potential, what we are discussing previously. So what is the experimental electric circuit drawn by the Ohms, George Simon Ohm? So he finally formulated a relation between current and potential, or a current and potential difference in the year of 1882. Then what is that law? How he can establish it? What is the electric circuit diagram for the Ohm's law? Very simple. He can take one point. That point he represented as a P. From the point of a P, he can take one conductor and connect it to the one end of an ammeter. Ammeter is a sensitive electronic device. It can measure strength of electric current in the circuit. So it measures the strength of electric current in the circuit. The second end of the ammeter is connected to the positive electrode of a cell or a battery. Then another electrode, that means negative electrode of the battery, is connected to the one-way plug key. Then another end of a one-way plug key, the second end of a one-way plug key is connected to another point of Q. From the point of Q, he connected it to the another sensitive device. That sensitive device he called as a rheostat. Rheostat is a variable resistance. Symbolically, it can represented as a RH. So the resistance in the circuit is a various. Then it can be represented as a rheostat or the variable resistance. Here they connected to the key. Key can be represented as a K. Key means to make or break the electric circuit is said to be key. Here they connected to the battery B. Battery means a source of an electric current. Then between the points P and Q, he connected it to a conductor. Then that conductor is called as a resistor. Between the points P and Q, he connected to the conductor. That conductor is said to be the resistor R. Then he can take a voltmeter. Voltmeter is a sensitive electronic device. It can measure potential or a potential difference between the 2 points of a conductor. Then voltmeter can be represented as a V. This is the symbolic or electrical symbolic representation for the voltmeter. Like this, he has connected a simple electric circuit, and then he make the key. When he make the key, then current passes through the circuit. When current passes through the circuit, he adjusted the rheostat. When he adjusted the rheostat, one end of the rheostat offered the maximum resistance or the maximum opposition, then another end is a vice versa. When another end is a vice versa, therefore he kept at a maximum position. The maximum current passes through the circuit. That current is noted down by the ammeter or measured by the ammeter. With respect to the current, what is the potential is a changes between the points P and Q, that is noted down by the voltmeter. Then after he break the circuit, that means he remove the key. When he remove the key, then the circuit is a break. When the circuit is a break and adjusted the rheostat at a minimum position, that minimum position of the rheostat we can representing like this. When we have to represent the minimum position of a rheostat and then making the circuit, when he has made the circuit, the small amount of a current passes through the ammeter. With respect to the current, the voltmeter potential is measured by the voltmeter. With respect to the current, potential is measured by the voltmeter. Then with making the circuit, rheostat gradually increases. Then current in the circuit is also gradually increases. Whenever current is increases, then potential also increases. Therefore, the strength of electric current through the circuit is gradually increases. He has observed potential in the voltmeter V is also gradually increases. Then after, with the help of a rheostat moves backward direction. Therefore, current in the circuit means ammeter is gradually decreases. Whenever current is decreases in the circuit, potential also decreases. Therefore, here finally he was observing this current increases, potential increases, current decreases, potential decreases. This he can observe at a constant temperature for the given conductor. At a constant temperature for the given conductor. Due to that, he established a relation. That relation we called as Ohm's law. What is that relation? The strength of electric current is directly proportional to the potential or potential difference crossed by the conductor for a given conductor at a constant temperature is said to be Ohm's law. This is the mathematical relation for the Ohm's law. Once again, I am repeating the statement or the definition for the Ohm's law. The amount of a current or the strength of a current in electric circuit is directly proportional to the its potential or potential difference for a given conductor at a constant temperature is said to be Ohm's law. Or this Ohm's law is again defined in a different manner, that as at a constant temperature. At a constant temperature, the current passes through the conductor is directly proportional to its potential difference. So at a constant temperature, I is proportional to V. It is said to be the statement of Ohm's law. Now we remove the proportion using the constant, that as I is equal to 1 by R into the V. Here R is said to be electrical resistance of the conductor. It is the proportionality constant. This proportionality constant is said to be electrical resistance of the conductor. From this equation, we can make potential or potential difference V as a subject and do the cross multiplication. V is equal to I into R. This is another representation for the Ohm's law. Is the according to the definition of a Ohm's law, the representation I is directly proportional to the V. Then from this, V is equal to IR. R is the proportionality constant. It is said to be electrical resistance of the conductor. What is meant by resistance? What is meant by resistance? How to define the resistance? Resistance means opposition offered by a conductor or opposition of flow of electric charges by the conductor is said to be resistance. Then resistance is represented as R. So the resistance of the conductor is represented by the R. The conductor which is having the property of a resistance. Resistance means opposition of a flow of electric charges is called as a resistance. Conductor which is having the property of opposition, then it is called as a resistor. Then it is called as a resistor. Electrical symbolic representation for the resistor is this. This is the electrical symbolic representation for the resistor, and then its resistance can be represented as R. This is the representation for the proportionality constant from the Ohm's law, that as a resistance and the symbolic representation of the resistor. This is the Ohm's law. Then according to this equation, we can write a magic triangle for the representation of a Ohm's law. Then first equation we can get V is equal to IR. From this equation I can make current as a subject. Current I is equal to V by R. Then from this equation I can make R as a subject, means resistance of the resistor as a subject. R is equal to V by I. These are the three mathematical relations for the Ohm's law. These three mathematical relations we can represent it as a triangle. Such a triangle we called as a magic triangle. Let us draw an equilateral triangle. these three equations, 1, 2, 3, these three equations we can represent a triangle. Such a triangle is said to be magic triangle. That as a triangle can divide it into three parts. First part, second part, and third part. First part we can take into the V, second part I, third point part is a R. If we have to calculate the potential or the potential difference in the circuit, just you have to close it, then we get the relation potential V is equal to I into R. Suppose you need to calculate the current I, then close into the current, we can get the relation V by R. Suppose we need to calculate the resistance R, close it the resistance, then we get V by I. These are the three relations for the Ohm's law. These three relations we can represent it as a triangle. Such a triangle is called as a magic triangle. This is the a simple explanation given by the Ohm's according to his law. What is the Ohm's law? At a constant temperature for the given conductor, strength of an electric current is directly proportional to its potential or potential difference.